Anagalactic, bringing you another science presentation. Ruger Josip Bošković. He wrote a most interesting book. If you're an astronomer, you may have heard of this man. He was a Jesuit priest. His birth coincides approximately with the death of Sir Isaac Newton and Leibniz, who died within a short span of each other. Each man invented half the calculus. Well, I suppose you could make a case for that, but the important thing was the principle of calculus. Ruger certainly refers to both Newton and Leibniz, and I should probably introduce for those force mechanics theory of universal physics, which is quite a mouthful. No one has ever even challenged his work. The force mechanical basis of universal physics. Now, you've heard of quantum mechanics. And what is mechanics? This is actually difficult to say because it's so basic. But Ruger discovered that there are two forces in balance in the universe. This is so basic that it affects quantum mechanics. He basically directly addressed the quantum mechanical paradox, and he explicitly transcended Newton. His discoveries prove my work, and my work proves Ruger's discoveries. The strange thing is they don't actually require any proof. Ruger supplies all the proof. Theoria Philosophiae Naturalis, which was published essentially, there were 3 editions, but 1758. 1758. That's quite a while ago, of course. More than 2.5 centuries ago. I see the lab cat is back. What Newton discovered was one force. Ruger developed a two-force system. A two-force system instead of a one-force system. Not very many people know about this, but what is very interesting is that more and more top-notch physicists are reporting that they have noticed it. It's the basic philosophy of physics. But to change the foundation of physics does not seem like a practical matter. Not so, although Ruger is clearly and fully aware the same incredulity would take hold. It went completely ignored. Well, at the time, during his lifetime, it did not go ignored at all. He was the most respected scientist in Europe because he was one of the men who was concerned about the discovery of a new object in the sky, which turned out to be the last planet, Neptune. He ran the Brera Observatory in southern Italy. But what he worked on, he began writing about continuity. And continuity is something that everybody has an intuitive grasp of. This has a lot to do with intuition, by the way. The continuum. Either the continuum of time or the continuum of space. I believe we were all at least exposed to this concept of continuity. It's so basic that it could be presented in such a way as to make it elusive because it has so many applications. There is a continuity of many things. The continuity of water, the continuity of the sky, the continuity of your body. But the more abstract ones are space and time. And it gets more specific, as you might imagine, since space and time are themselves quite abstract concepts. So the continuity, already abstract, of space is one subject that Ruger covers. And he also covers the continuity of time. And you might be getting a little antsy, I know I would, a little nervous. Isn't this very one-sided, very one-sided? Because what about particles? What about exactly? If that was your intuition, your thought, what about particles? He talks about particles the most. His book, Theoria Philosophiae Naturalis, can be divided into 2 words that fully explain his theory. Continuity is one of them. The other one is the common perception of the particle, the common perception of a point. I will extend and show you that this is equivalent to the quantum and to a linear number. That's four things that are all the same. That is, they have the same, there's something the same about them. The particle, the quantum, the number, and the point. The common term for these four terms, number, this would be a linear number, I should be specific. A linear number such as you and I were taught in school, 1, 2, 3, 4, that has something in common with a point. Now, I believe that's the simple, we all know that. A point and a number are considered to be the same thing. So is a particle. And the thing about the particle is that you need to say right now, the definition of the particle, you have to choose a definition of the particle, and you want to be careful how you choose to define the particle. But here what we want to do is define the particle by what it's not, by exactly what it is not. It is not continuous. Then you have to add something because that's a negative definition begging the question. What is a particle? Okay, it's not continuous. That's the first thing you have to say. The second thing you have to say is that it's indivisible. But Roger does not use that word. And there are several words for this. What it means is rock hard. It means it's a thing. You have to actually be more specific about that at the quantum level, though. And what is meant even at the quantum level? This stays continuous all the way down to the paradox, all the way down to the split, where basically our number system splits. Our physiology cannot cope with our level of insight yet without the correct geometry and mathematics. We simply cannot understand quantum mechanics. It cannot be done. It's not been done. Nobody has ever understood quantum mechanics. But it's really a question of what is it you're trying to understand. And when you know what that is, all of this makes sense. That is what Roger says. Is what you're trying to do is define an indivisible particle. This would be a quantum, or a point, or a number. That's how we conceive numbers, and I've given several presentations on this subject, but I'm just summarizing it now, because now is the time to do it. Because you have to summarize everything to keep up with Roger. This is so simple that it's virtually magic. It's virtually miraculous. And it raises a lot of questions like, am I at the mystery spot? Is this an illusion? No, it's not an illusion. And I will tell you that on great authority. But let's explain what this is again. The more you understand this, the better off you're going to be. Because Roger got it. He got the solution to the quantum paradox before the quantum was discovered. And in fact, it's Roger who did discover the quantum and can prove what it is so that you and I can understand it. And that's 25 minutes. I've got to tend to certain things in my life. But I wanted to give you this less than a half an hour presentation to let you know what you're in for until the summer solstice. I will be talking about Roger's work. And in the next presentation, I expect that you are very likely going to have your socks rolled up like no big O has ever done an O on you in your effing life. Because I'm not kidding you when I say that Roger got the solution to the quantum paradox, such that it's not a paradox anymore. That is a miraculous insight. He also did it without calculus. He also did it using pure geometry. But it's an algebraic solution, though. What I discovered, and what I discovered before I knew of Roger's work, I knew a year before I discovered what I just told you that Roger discovered, I discovered the number system in which his algebra works. And if that isn't enough to get you to tune into the next presentation, it's the spherical number system, and it's the same spherical number system that the Greeks used, called proportional numbers, which you and I know as fractions. You may know that fractions that have a 1 in them are special. 1 over any number is a very special form of fraction. But any linear number over 1 is itself, correct? That's a very interesting identity, because that number over 1 is a 2-component number. 2 can be rewritten in spherical notation such that it generates the geometry of the number system based on proportionality, which is the multiplicative, that's hard to say, multiplicative divisional operator system that does not work on the line, because only add and subtract work on the line. But we're using linear geometry and linear mathematics for everything, including quantum mechanics and space-time. And I am now capable of sharing with you the true meaning of both of those incredible accomplishments using this new geometry, but fully explained by Roger's force balance system based on continuity and impenetrability, the two basic concepts in the universe. There is nothing more basic in all of science than physics, that is. There's nothing more basic in all of physics than these two principles, and that is the correct word. These are the two balancing principles. And the reason we can use the word balancing is because they are forces, and they're the only two forces in the universe at the quantum level. And that will generate automatically, right out the gate, right out of the dugout, right off the bat, that generates the unified field solution. It is the unified field solution, and it explains every single quantum paradox, including entanglement, superposition, the collapse of the wave function. That is the most important one, and we're going to cover all of that again, and we're going to synthesize it again, but this time we're going to be guided by the work of the greatest scientist who ever lived, ignored for 2 centuries. He was the most famous physicist and the most famous mathematician in Europe after Leibniz died, which was right after Newton died. Maxwell knew of this man's work. Faraday cited it. Bohr cited it. Many other top-notch physicists have cited Bošković's work. Tesla knew of it intimately, but did not talk about it. We're going to go through Roger's work and compare it with contemporary physics and quantum mechanics. It's quite emotional. The cat could take it, so can we. We'll be right back.